It's time for a long-awaited and often requested processing tutorial. This one is for one-shot color camera data. We're going to be combining RGB data with OIII L Ultimate, that's hydrogen alpha and oxygen 3, and ASCAR D2, that's oxygen 3 and sulfur 2 data. We're going to put that all together to produce an SHO image with true color stars. Right, let's get started then. We've got our three integrated stacks here. At the moment we can't really see anything, so let's do an unlinked screen transfer function on these one at a time. So this first one is our RGB data. This is taken using an OIII L Quad Enhance. The quality of the nebulosity here is rubbish, but that's okay because it's only 30 minutes of data. We only need 30 minutes because this is all about the stars. We don't care about the nebulosity, all about the stars. Okay. So that's our first one. And then over here we have OIII L Ultimate data. This is hydrogen alpha and oxygen 3. And we don't care about the stars at all, but we do care about the nebulosity. And then our third view over here is taken using an ASCAR D2 filter. So that's oxygen 3 and sulfur 2. And similar to the previous image, we don't care about the stars here. We're going to be getting rid of those, but we do care about the nebulosity. So our final image that we're going to produce at the end of this whole process will combine the nebulosity from these two images and the true color stars from this image. The first thing I'm going to do is integer resample because my data is oversampled. So let's do L quad first. We're going to downsample by 2. And then we'll do our L ultimate, downsample by 2. And then our ASCAR D2, downsample by 2. If you're not sure whether you should downsample or not, then there's an article on my urban astrophotography website all about integer resample and binning and whether you should do it or not. After I complete each step, I tend to make clones of the images and then save. I just put the originals out of the way so that I can always go back a step to whatever step I want to in the processing if I mess anything up. Right, so we've got our 3 images here. The next step is to make sure that these are all aligned up perfectly, because at first glance it might look like they are, but actually we can do a little experiment just to test. If we make 2 of the windows exactly the same size, and then we'll drag that name over there, that'll make them match. And then if I hold Control and page down, it will flip between the last 2 windows. You can see they're not lined up. And the L quad clone won't be either. So what we need to do is star alignment. We're going to go with a view, and we're going to use L ultimate clone as our reference view. And then our targets are going to be the other 2 clones. That was L quad and D2. And then we are going to click on the little circle button here. This produces 2 new images. Let's just give those a little stretch. Okay. And we don't need the original ones because they're out of alignment, aren't they? Oop, I closed the wrong one. Never mind, that's why we made the backup here. Right, so now these 3 views will all be lined up. However, you can see that the L quad in particular, but also the D2 a little bit, have had to be cropped so that they'll fit. So what we need to do is a dynamic crop to make sure that the crop for all 3 of them matches. We don't want to do it on D2 to start with though. Oops. What we want to do is select the image that has the most in terms of the black bars around the outside. So that's the L quad. We're going to run dynamic crop. We're going to hold down Control and we're going to crop it in and move this box so that it's just about, so we've got as much of the view as possible but none of the black box. And once we've done that, we're going to first apply this crop to one of these other images. Let's choose D2. So we do that by taking that little triangle and we drag and drop it over onto D2 and then over onto L Ultimate, and then we can just tick there and it'll apply it to L Quad. And this means that all three of these images will now be perfectly aligned. I'm going to rename these to be aligned and then make copies of them. And just to confirm that these are lined up, again we'll make sure these windows are the same size. We'll drag one name over to the other to make the views line up, and then control and page down. You see, lined up perfectly. And the same is true of the L Quad as well. The next step is to run gradient correction. So I'm going to open that now. This will smooth out the backgrounds of our pictures. Now, for these, I'm no expert in gradient correction, but the gradients aren't too bad, so I'm going to put the scale and the smoothness fairly high, matching about there. And let's give that a go on this one first. Okay, it didn't make a huge difference, but a bit of an improvement, I think. And now on this one. And then finally the D2. Obviously I'm doing this quickly here, but when you're doing it you can play about with different settings and make different versions and just see what gives you the best result. Don't just blindly copy my results. Now we want to run image solver on all three images. That's going to give, it's going to analyze the pictures and give PixInsight some information to work with, which is going to be useful for future settings. So we need to go to Script, we need to go to Image Analysis and Image Solver. We're using the active window at the moment, which is the L Quad. This should all be filled in already if you're using an Astro camera with a FITS file format, and we're going to click OK. And then the same for the L Ultimate. Script, Image Analysis, Image Solver. Then it's the turn of the D2. Now we're going to run Blur Exterminator on each of these images in turn. Blur Exterminator and some of the other scripts that I may use might not be the default ones. I honestly lose track of which ones come with PixInsight and which ones are extra plugins. So if I use any process or any function that you don't have when you're following this along at home, then just Google the name of it and you'll be able to install it pretty quickly, I'm sure. When I run Blur Exterminator, I first, as a precursor, like to run PSF image, and this will analyze the view and give me a number that I can put manually into Blur Exterminator to get a better result. So I'm looking here at the full width half maximum on the X and Y axis of the stars in this L Quad view, and we want a number that's between those two, so like 1.41 would be fine, okay. And I'm going to run Blur Exterminator and put in 1.41 there. And again, you can play about with these settings, but I'm doing this quickly, so I'm going to leave these on the defaults, and I'm going to run that just like so. Then it's the turn of the L Ultimate. So again, we're going to go to Script, Render, PSF Image, and Evaluate. We want an approximate number between the two, let's say 1.47. That would work here. And finally, we're going to do it for the D2. Script, Render, PSF Image, Evaluate. And a number between these two, let's say 1.44, close enough. Blur X 1.44. It really doesn't need to be exact, I don't think, but that'll do. Kapow! Those three are done. Let's rename these and then make copies. data. Next we're going to run SPCC, which is about the colour of our images. We'll do it to the LQuad first. LQuad is broadband data, so all this is fine, all the default here. We need to choose a blank bit of background, so we're going to select the preview icon up here and just try to find something that looks a bit empty. Mostly empty. There's a few stars there, that might not be the best one. Something that's empty. Actually, you know, this bit of nebulosity there is quite dark, isn't it? Let's go with that. Region of interest from preview that we just selected. And then let's run SPCC. When it's finished, it'll look a bit like this. We can close that. We can right click on our preview, click delete, and then we can run an unlinked transfer to get the view back. Now let's do the same for our ultimate, only this is narrowband data, so we're going to click narrowband filters mode, and the ultimate has bandwidths of 3 nanometers, so we can put 333. But we do need to do the region of interest again, so let's find something that looks kind of empty. Let's just go with this bit. That might not be the best one because it is part of the nebulosity, but if it doesn't work, then you go back and try something different. Here we go. Let's take a look. Vibrant. And then the same here. The difference being that this is ASCII-T2, which has bandpasses of 6. Let's put 666 and run that. Okie dokie. Now we want to stretch the data from a linear to a non-linear state. Lots of different ways to do this. If we were doing it in loads of detail, we do GHS, but we're doing this fast, so I'm going to use Easy Soft Stretch, which is super simple to use. So we've got our LQuad first of all, and then we're going to soft stretch our ultimate. That's the one, isn't it? And then our D2. Let's rename these and make some clones of them. The next stage is about star removal. Let's just minimize these two, put them out of the way, because we're going to begin with the LQuad. And the stars are what we're interested in here, because if you remember from the beginning, these stars are they're true color stars because they're broadband, not narrowband, and these are the stars that are going to end up in our final image. We don't care about the nebulosity. So what we need to do is create a clone of that, and we're going to open up StarNet. Some people use Star Exterminator, but I find StarNet, it works just fine and is free. We've stretched the data so it's not linear anymore, and we're just going to run this to take out all of the stars. Okay, now we want to use a function called screen stars, and this is going to remove the stars from this image and have them as a separate image that we can then put into our view, our image right at the very end. So we want script utilities screen stars, there it is. We're doing star removal. Our star review is this one, L quad easy clone, L quad easy clone, and our starless view is this one, which is L quad easy clone clone. Let's run that, and hey presto, we have our stars. We don't care about this, and we don't care about this one anymore. So these are the stars that we are going to use. I tend to find that they can look a little weak, a little anemic. So I like to boost the saturation of the stars. This is a good time to do that. Now, to boost the saturation of the entire image rather than a specific colour, it's a bit tricky to see. There's a little yellow dot there, so we get that and boost that. I do it right to the top and press square, and I like to then press square again so it runs it twice so that we get nice colourful stars. If you find it's too colourful for you, you don't need to do it to that extent. I also like to run a bit of SCNL green to take out any green, because there shouldn't be any green in our stars. Right, now we're going to minimize that and put that out of the way. We'll need that again at the end. Now what we need to do is remove the stars from our other two images. And it's even simpler than what we just did, because we're not making any extra star images using screen start or anything, so we are simply removing the stars. That's done for the ultimate, and let's do it for the D2. Looking good. Let's rename these and make some clones of them. I've just noticed there's an artifact that's been left behind here on the D2 from the star removal process. Let's fix that, shall we? We want clone stamp. Choose a nice big radius. And I always forget how to do this. Control and click. Okay, done, fixed. Soon we're going to combine these two images into one SHO image, but the result we get is dependent on the relative strengths of these two pictures here. So we can see that L ultimate looks a lot brighter and is better defined than the D2 over here. Now that isn't a surprise, because the L ultimate captures hydrogen alpha, and that's stronger in most objects because there's loads of it, whereas the sulfur and the in particular, but also the oxygen is weaker. So what we can do is give this view a little boost so it more closely matches this one. So let's go to our curves transformation and just give it a bit of a boost. Give it a little bit of a curve. Just so that it's a bit brighter and a bit more comparable. Now this is a really important step actually, because you can play about with both of these views before we merge them if you like, and like I said, the end result you'll get is quite different. So you might like to make a few copies of these and make different versions of them and just mix everything up and just see what results you get. Have a play about with it. But how do we combine them? So we go to script, we go to utilities, and we go to db extract. And we need to put our sensor in here. I'm using a 2600 camera, and that uses the IMX571 sensor. You can just Google your camera and you'll find out what sensor it is. The hydrogen alpha and oxygen 3 filter view is our L ultimate starless clone here. L ultimate starless clone, and our S203 filter is our D2 starless clone here. D2 starless clone. Let's leave those two optional ones and click extract. Okay, and this is the result that we've got. We don't need these ones, so we're going to close those. Now we can see This is pretty cool. It looks very green. Maybe we left in a bit too, maybe we didn't strengthen the D2 a little bit. So just for a comparison, let's make the D2 even stronger and then run through that process again. So let's do our curves and then give that even more of a boost. Getting a bit noisy, but we'll solve that later. And then let's run that whole process again and see what we get. Okay, so you see when we strengthen the D2, we get different color palettes. So really you just have to play about with it and see what you like. Let's just go with this one for now, just because in general I like to have lots of different colors that we can then play about with. So I'm going to make a clone of this. And a useful little utility is correct magenta stars. And if we run this, it can often have a positive effect on the colours, I find. And we can play about with the colours in other ways. I have some masks here. These are from Bill Blanchard and Mike Cranfeld. They made these little scripts that are very useful. So I'll just give an example. Let's take a yellow mask, just so that we can select what's yellow in the view, and we'll blur that. And then if we apply this mask, but we don't need to see it, so we'll take that away using that little icon. Now what we can do is modify all just the yellow, and we can make that look a bit more red, and we can just have some fun. Okay, make it, what if we wanted a deeper red? For example. And let's take that away. And what if we wanted to play about with the blue, for example? Let's put on a blue mask there. There's not so much high quality data. Let's just go with it, see what it comes out like. What am I looking for? Curves. Hang on, sorry. And what would happen if we played with the blue there? You can see the difference it makes. Now I'm just having some fun trying to make some quite extreme colours, just to make the point that you can mix this up like however you like, really. So it's good just to spend some time adjusting this to however you want. This is more vibrant than I would go with, really, but just to give you the idea. Okay, let's say that let's just pretend that we've got the colours how we want them, just for argument's sake, and then I'll go on to some other things that you can do. Dark structure enhance is very useful. Let's run that, and that should make all these darker areas pop nicely, and you can run that multiple times if you want to. And unsharp mask is also a very useful one. Let's take a close-in view. Now we don't want the background to be too mottled. If we click this little circle up here, we can see before and after, but it does sharpen it up quite a bit. I always forget for this one you need to drag the triangle over. And we haven't run any noise reduction, have we? So let's bring out our noise reduction. Let's just set that to 50, but again you can do it lower and run it a few times if you want to. And that's looking quite a lot smoother. let's a little bit of local histogram equalizer might be good. Default's way too much. But if we turn that down, yeah, it's a bit punchier, isn't it? Let's run that. You can spend a long time playing about the colours, and I encourage you to just try different things, really get into it, see what you like. But for argument's sake, let's just pretend that we're happy with that. We're going to call that starless, because we now want to put the stars back into this image. So to do that, we're going to go to Script, Utilities, and we want Screen Stars. We're doing star replacement this time. Our starless view we just called starless, and our stars view is stars. That's the default from what it was called before. You can see it's peppered the stars back in. So let's click on the tick there. And here we go. We have our stars back in. And you know what? They are looking good because they are the proper color broadband stars, and they're not too anemic because we boosted the saturation of them quite a bit. Hooray! Alright, what I would do now is a few more, like rerunning some of those steps, might try and sharpen a little bit, but not too much more on-screen unsharp mask because we have put the stars back in. But you could run, I don't know, let's just do it for a laugh. Let's do a bit more dark structure enhance, maybe not quite as much. Yeah, just make that pop a little bit more. We could, for example, play about with our curves. You should do most of this before putting the stars back in, to be fair. But I'm just showing you the kind of thing you can do. And then as a final step, if you used integer resample at the beginning, we can get that resolution back. Starry is the one we've got. We can upsample by 2 and have lots of lovely resolution. So that's the gist of how you can take the Optilong L-Ultimate and ASCII RD2 data, but it would work with any of those dual band filters that capture all those different wavelengths to get an SHO image from an OIII camera. I hope that was useful. Thank you very much.